Hello all, welcome to part 11 of the Assembly Language Primer for Hackers video series. In this video, we will look at how to go about passing arguments via the stack to a function. So we've taken a very simple sample program which defines a main function and another function called the addMe function. The addMe function takes two inputs, int a and int b, and then computes their sum and returns it. Right? The point to note is that in addMe we also have a local variable c. Now the main function simply calls addMe with the values 10 and 20 and goes ahead and prints the result with a separate routine. Now we've not defined the print function here just to keep it simple. So let's look at how the program would go about executing. So first, when main is called, what happens is the addMe function gets called. Now even before the addMe function starts executing, the values 10 and 20 need to be passed to that function. Now this is done via the stack. What happens is that in the main function, 10 and 20 are first pushed into the stack. Now once 10 and 20 are onto the stack, the value of ESP, which generally points to the top of the stack, is updated. At this point, before function addMe is called, one needs to understand that there needs to be a way after addMe has done its job and exits, how to go ahead and start with the next instruction, which is print. Now in order to do this, the instruction print's memory location is actually stored onto the stack, and this is what is called the return value or the ret. So at this point, what we have on the stack is the local variables, the return address after executing the function addMe where the program needs to execute next, and at this point one can go ahead and enter the addMe function. Now there is something very interesting here, is that once inside the addMe function, local variables such as c needs to be defined, int c needs to be defined, and there are many other tasks which need to be done, right? So right now the ESP is pointing to the top of the stack, which is where the return address is. Now ESP itself may be used inside this function in various ways, and thus it might not be possible to preserve this value of ESP when you get back to main. Now this is undesirable because many of main's own local variables etc. would be on the stack and need to be referenced with ESP. Now to get around this, what we do is first of all go ahead and use the EBP register in order to save the state of ESP. So to do that, one needs to understand that the EBP register itself might have been locally used in the main function for various things, and thus even its state needs to be saved. So the first thing one does once we enter the addMe function is to go ahead and save the old value of the EBP register. Once this is done, ESP is updated to this point pointing to the top of the stack. Now we go ahead and copy the value of current ESP into the EBP register. Once this is done, the EBP register always points to the top of the stack as far as the local function addMe is concerned. From there on, let's say if you want to reserve some space for the local variable integer c, we go ahead, create that space and update ESP accordingly. And then depending on what other things we do with the stack, ESP's value could change. So just to kind of go ahead and summarize, the arguments which are passed to a function are stored on the stack, then the return address is stored, then the old value of EBP is stored, and then EBP actually points to the top of the stack at this point when we enter the new function. And then from here onwards, all the local variables for the function will be stored and ESP will be changed accordingly. So now let's look at how once you're inside the function, it is possible to go ahead and retrieve all these arguments to addMe using the EBP register. So very simply, if you notice, EBP currently points at the juncture where the old EBP was actually saved. So if you remember, the indirect addressing mode in registers we can actually use the EBP register to reference any one of these arguments which were passed, the return value, etc., and even the local variables in the addme function. So how do we do it? Well, if you remember in indirect addressing mode, when percentage EBP is actually inside parenthesis, then what this actually means is the memory location where the EBP register is actually pointing to, right? Take that value. So if you note, this is nothing but the value of EBP hold 4 outside, and then percentage EBP is nothing but going to be the value, the return address which is stored on the stack. Similarly, 8 EBP is nothing but the first argument which is going to be stored on the stack, and then 12 EBP is the second argument, right? So now let's go and look at a live example of how we can use this scheme in order to create a very simple function where we use the stack to go ahead and pass arguments. So I've written a very simple program, function 3.s. In the data section, I've mentioned a string hello world, and then in the text section, I've defined a print function. So if you notice, in the print function, we've done nothing but use the write syscall. Now this is exactly what write is. We go ahead, do everything. But before we get into this, let's look at the first two instructions. So if you go back to the slides, the first thing we do is actually go ahead once we are inside the function. So actually even before that, let's actually scroll down and look at what we are doing here. So if you remember, the write syscall, it requires two important parameters. One is the string length, and another is the pointer to the string itself. So we need to push both of these onto the stack, right? And this is the instruction where we are pushing the string length, and this is the instruction where we are pushing the pointer to the hello world string onto the stack, right? So after this, we go ahead and call the print function, and in the end we go ahead adjust the stack because we pushed in these two 4-byte values, which means 8 bytes. So we go ahead add 8 to the value of ESP to restore ESP to the same state before these two pushes. Now the reason we add 8 instead of subtracting is that the stack grows down in memory, right? So basically after these two pushes, what we have is these two arguments onto the stack. Now when the call instruction is actually executed, the return address of the next instruction, which is the addl 8 into ESP, is stored onto the stack. This is where the return instruction is. Now if you remember, once we are into the new function, the first thing we need to do is store the old value of EBP. Now let's scroll up. So if you look here, this is where we are pushing the value, the old value of EBP onto the stack. The next thing was actually to go ahead and store the current value of ESP into EBP so that we can reference all these arguments, etc. on the stack. Now this is the second instruction where we are moving the current value of ESP into EBP. So think of this as kind of a preparation, where we have gone ahead, stored the old value of EBP, and then stored the current value of ESP into EBP. Now from here on, we can use the EBP register to go ahead and reference any one of the arguments on the stack. So now let's go to the familiar write syscall. We store 4 into EAX. 4 is nothing but the syscall number for write. Then we go ahead store 1 into EBX because we want to write on std out. Now comes the interesting part. Move L8 inside parenthesis EBP into ECX. Now what does this mean? This means whatever is stored inside EBP, look at that as an address, add 8 to it, and then whatever that address points to, take 4 bytes and store it into ECX, right? So what does EBP actually point to? EBP points currently to the old value of EBP which we just stored onto the stack. So what does EBP plus 8 actually point to? Well, that would actually point to the first argument which is there on the stack, right? Similarly, 12 EBP would actually point to the second argument. Now, in both these cases, if you remember, the first argument which we can retrieve is actually going to be the pointer to the hello world string. The second argument is actually going to be the string length. And then we go ahead and issue the interrupt, so that the syscall can execute and printing happens. Finally, once we are done, we go ahead, take the current value of EBP, which was what the previous ESP was when we entered the function, and restore it back into the current ESP register. What does this help in? This helps in go ahead and freeing all the local variables which might have been allocated using the ESP register. Then we go ahead and restore the old value of EBP by popping that from the stack. Right? And then finally we go ahead and execute the ret instruction, which goes and pops back the return value into the EIP register, so that we can now execute the next instruction, which is addl. Now let's go ahead, assemble this program and see exactly how it runs. Let's link it. Then let's execute it. So if you notice, the hello world string is printed to std out. Now let's load this into GDB and actually look at exactly what is happening. Let's list the program. Let's go ahead and add a breakpoint right here. So run the program. So we've hit the breakpoint now. So the first thing we need to do is look at exactly what is ESP pointing to right now. Right, so this is the address where ESP is pointing to currently. Now let's look at exactly what is there in this memory location. Okay, there are some values which are there onto the stack right now. So the next instruction, push 13, is actually going to go ahead and store that onto the stack. So let's step through the instruction, and now let's actually go ahead and look at the stack. So if you notice, the value D in hex has been stored onto the stack, which is nothing but 13 in decimal. The next instruction is actually to go ahead and push the address of the string hello world. So what is the address of hello world right now? Let's print that. And now let's step through the instruction and print the stack again. So if you notice, the hello world string is at this address, and this is exactly what has been pushed onto the stack. Now the next instruction is actually to call the print function, right? So if you remember, as soon as we execute this instruction, what is going to happen is that the next address where execution should start after this print function returns should be stored onto the stack. Once again, this is the return value. So we've seen these two arguments currently stored on the stack, the string length as well as the memory address of the string. Now we are going to call the function, and once the call is executed, the return address should also be stored on the stack. So let's predict the return address. Let's go ahead and disassemble the start routine, and if you notice, this should be the next address, right, after the print function returns. So let's step now through the code. Now we actually come to the print function, but let's look at exactly what is there on the stack now. So if you notice, now the stack contains the return address of the next instruction, which is the add 8 to ESP. So what is there on the stack? On the top is the return address, then we have the memory location for the hello world string, and then we have the string length for the hello world string, right? Once again, back to the slides, return address, first argument, second argument. So now what we're going to do is push the current value of EVP onto the stack. So the current value of EBP is actually 0. Anyway, let's step through the instruction. Let's look at the stack again. Now if you notice, the value 0, which is of the current EBP register, is actually onto the stack. Then we move the current value of ESP into EBP. The current value of ESP is this. Let's step through, and then now let's look at exactly what is there in EBP, and it is the top of the stack. So from this point on, you're going to execute various parts of the write function, write syscall. So let's step through these instructions. Now is where the interesting part comes in. So in this particular instruction, we go ahead and load the string pointer into ECX. And this is where we need to look a bit deeper. So now let's look at exactly what is EBP pointing to. So EBP currently points to the top of the stack, right? And if you actually notice, let's go ahead and examine that specific piece of memory. So first, the old value of EBP is what is on the stack. Then we have the return address, and then we have the pointer to the hello world string, and then finally the string length, right? So EBP is pointing here in the beginning, which means 4 bytes first would actually go ahead and cover the old value of EBP. The next 4 bytes would actually go ahead and cover the value of the return address. And then the 8th byte onwards till the 12th byte is actually going to go ahead and cover the exact string pointer. And this is what move L8 and then inside parenthesis EBP is going to do. It is going to go ahead, take this value and store it into ECX. If you're confused about this notation, go back and look at the video moving data where we talk about indirect addressing mode using registers. So let's step through this instruction. Now if we actually examine the value of the ECX register, we will notice that this now points to the string hello world, and we can go ahead and verify this. This is the hello world string. The next instruction is actually going to copy the string length into the EDX register. So if you notice, this is what the string length actually is. Step through the instruction. And now let's look at the value of EDX. Which is 13. If you remember, this was the string length. Then we go ahead and issue the interrupt. This actually prints the value of hello world onto std out. Then we go ahead, restore the current value of we restore the value of ESP to the old value, which is pointed to by EBP. Then we go ahead and pop the value of EBP from the register. So because of this pop, now if you go ahead and look at the top of the stack, what you should find is the return address, and then you should go ahead and find the 2 arguments, right? So now let's step through, and if you notice, the return address will also be popped automatically. Now if you look at the top of the stack, the return address has been popped off, and what we have here is now the 2 arguments, right? And then this is the next instruction, which is going to be adding 8 to the value of ESP. Now if you look at the top of the stack, you will notice that it is exactly back to the 0, 1 which it was pointing to at the beginning of the program. So, well, that's all for this video. What I wanted to demonstrate in detail is how arguments are pushed on the stack, how the return value is pushed. EBP is actually used as a reference pointer in order to figure out arguments on the stack as well as local variables, etc. And then how all this weaves in together to be able to help the program get that memory where it can go ahead, store variables, store arguments and everything. I would encourage you to download this example and try this out. This is a slightly advanced example, because of which probably you need to work with this a bit more to understand it fully. Well, that's all for this video. Would really appreciate if you can leave behind a couple of comments and whatever you've liked or disliked about these videos. I'd be happy to work on it. That's all. Thank you very much.